Now let's talk about databases in AWS. And first, I want to give you an introduction as to what is a database and the different types of databases we have today. So when you are storing data on disk, would it be on an EBS drive, an EBS volume, an EC2 instance store, Amazon S3, you have your limits. If you want to store data in a structured way, you may want to store it in a database. And this structure is going to allow you to build indexes and to efficiently query or search through the data. So while we have with EVFS, EBS, EC2 Instance Store, and Amazon S3, we can do per files operations. With databases, it's going to be a lot more structured. We can define relationships between your data sets. So these databases nowadays, they're all optimized for a purpose, and they will come with different features, shapes, and constraints. From an exam perspective, it's up to you to understand which database is going to fit best the use case given to you by the question. So the first kind of database that has been very common and is still very common today is called relational databases. So if you've used Excel before, you know Excel spreadsheets. This is just the same as Excel spreadsheets, but you have links between each table. So for example, we have the students table, and as we can see, we have 4 columns, and there's a student ID, a department ID, a name, and an email. And then, for example, you would have a second spreadsheet called the department spreadsheet, which takes the department ID and adds more information. And the idea is that in a relational database, you are defining a relation between the department ID, the second column in the students table, into the first column of the departments table. And you can even define more relations. For example, you can define a subjects table and link the table of the students to the subjects by defining another relation. This is why it's called a relational database. Now, in relational databases, the particularity is that you can use the SQL language to perform queries or lookups. So these, whenever you hear SQL, think relational databases. Next, we have NoSQL databases. NoSQL means non-SQL, which means non-relational databases. So NoSQL are new or more modern kind of databases. They're built for a specific purpose with a specific data model in mind, and they have a flexible schema for building modern application. A schema is basically the shape of the data. So the benefit of using a NoSQL database is that you have more flexibility. It's easier to make the data model evolve. It's scalable, so it's designed to scale out by adding distributed servers. So the example from before, the relational database, it's not easy to add servers to scale it. So you have to scale up by doing some vertical scaling, but with NoSQL databases, you can do horizontal scaling. It's also high performance. It's optimized for a specific data model. It's highly functional. The types are optimized for the data model. And finally, some examples of NoSQL databases are going to be key value databases, document, graph, in-memory, or search databases. We will be seeing those in this section. So, for example, in a NoSQL database, you can have the data in a JSON format. So JSON stands for JavaScript Object Notation, and we've seen it before. This is the same language we've been using when we defined our IAM policies, and this is what a JSON document looks like. As we can see, this does not look at all like an Excel document. So JSON is a very common way to describe data. And as we can see in here, we have different sub-nesting of the data. We have different fields, different names, different types. And so it is a very common way to model data in a NoSQL model. The data can be nested. For example, if we look at address right here, it is nested within the higher object element. So address and types are going to be nested. The fields can change over time, so it's up to us to add a new field into our JSON document. And there's support for arrays. For example, John, who is 30, has 3 different cars, Ford, BMW, and Fiat. He's a lucky man. Okay, so databases, as you can see, can have different forms, and we'll be seeing them in details in this section. So just some words around databases and the shared responsibility model on AWS. So AWS will offer to manage different databases for us. So these are the offering we'll see. And the benefits of using a managed database is that it's very quick to provision. Usually AWS will have high availability in mind when designing it. And if you want to scale your database, you can do vertical and horizontal scaling pretty easily. They will also include some utilities to do automated backup and restore of your databases, as well as operations and upgrades. And if you need to patch the operating system of the underlying instance, actually it's not your responsibility anymore. it's AWS's responsibility. So AWS will be responsible for the entire database in terms of patching. The monitoring and the alerting as well are going to be integrated. And so this is why using a managed database on AWS is very, very important and very beneficial. So you are obviously able to run your own database technology on an EC2 instance, but if you do so, you need to handle yourself all the things associated with resiliency, backup, patching, high availability, fault tolerance, and scaling. So this is why, in this case, using a managed database is going to be a lifesaver for so many of our use cases, okay? So in this section, we'll have a look at all the managed databases from AWS and which use cases they fit. So we'll see you in the next lecture.